There's a number of different elements that make up a swimming performance. And you need to treat each athlete as an individual and look at them holistically. High-performance athletes are very, very critical of themselves and responsive to feedback, whether it be something technical or something physical or something psychological even. The sooner we can give them the information, the sooner they can work towards making themselves better. We never talk about outcomes on their team. It's always about performance and process. Every athlete is like a Rubik's Cube, and you have to solve the problem to unlock that individual. And you've got to use what's around you, the information that you have, to learn what you can and to try and drive improvement and performance. Working in sport is about decision-making, planning and programming and developing the athlete to be the best that they can be. The more you can understand performance and the more insight we have into what's going on, the better decisions we can make. The biggest gains are going to come in the training pool. That's the F1 garage. That's where they're going to hone their performance and improve. Whatever we can enhance in that environment for them will only be beneficial. Who knows how fast they can swim? That's the fun of it. You just never know. We're always chasing perfection, but it doesn't really exist. There's always something to improve on. Preparation is everything. Knowing where your strengths and weaknesses are and being able to work on them now. The Olympics will be the end result. Knowing the work that's gone into the performance and then seeing the athlete touch the wall and then them turning around with like just this enormous smile on their face. They can't even believe what they've just achieved. That is just priceless.
Hi everyone, welcome to our session. I'm Annie Neve. I'm a senior data scientist with AWS, and I'm delighted to be joined by Jess Caronis, who's the general manager of the Olympic program for Swimming Australia, and who you just heard speaking in that opening clip. We are both based out of Australia, so before we dive into the presentation today, excuse the swimming pun so early on, you should all know that us Aussies are serious about our swimming. Most Australians live by the coast, so learning to swim is an essential life skill and a big part of our culture. But we also take it pretty seriously, and many of the world's best swimmers come from Australia. Raise your hand if you watched the Paris Olympics earlier this year. Keep your hand up if you watched any of the swimming events. Yep. Those of you with your hands up would have noticed that the Australian swim team, led by Jess, had an extremely successful Olympic campaign. For those of you that missed it, Australia won a very impressive 18 medals in swimming, with 7 of them being gold. This is just 1 gold medal short of the US swim team, who are our toughest rivals. But over the last few Olympics, we have been closing this medal gap with the US. So definitely watch out for us Aussies in the pool at the LA Olympics in 2028. And especially because Swimming Australia has a competitive advantage in the way that they are using technology to get the best out in their athletes. Seriously, they are using cutting-edge tech in a way that no other swimming organization is in the world. It's my privilege to be here with Jess to talk to you about the work that we're doing together and how AWS helps to power our high-performance athletes. First up, we're lucky to have Jess reveal to us a bit of her secret sauce to producing gold medal-winning athletes. She'll talk about the important role that technology and the long-standing collaboration with AWS plays. And in particular, she'll talk about the importance of harnessing technology in the training pool, because that's where the athletes are spending most of their time, and that's where they're honing their skills to get better. I'll then jump into the details of the most recent work that AWS Professional Services and Swimming Australia have been building together. This work is called Training Insights, and it's all about bringing the power of machine learning into the training pool. And I think it will inspire you all for the future of data and technology in high-performance sport. We're doing some cool stuff. We'll wrap up the presentation portion of the session with plenty of time for questions and answers at the end. So please, as we're going through, save your questions for the end. We're really lucky to have Jess with us, who has been to multiple Olympics. So it's a really good opportunity to ask her any questions. OK, so I'll now hand over to the very impressive Jess to tell us more about Swimming Australia.
Thanks, Annie. Thanks for having me here today, everyone. So I'm really lucky to talk to you about Swimming Australia today and how we're using technology there to enhance our athletes' performance with our coaches and performance teams. At Swimming Australia, we're coach-led, athlete-focused, and expert-supported. We've got incredible swimmers, some of the world's fastest, world-leading coaches, and performance support teams. We started working with AWS in 2018, and it's been a real expedition. The reason I call it an expedition is because we're going into new places that we've never been before, and we're doing things in world swimming that have never been done before in our quest for gold. But whenever we talk about technology in high-performance sport, what's really important is that we keep the athletes front of mind, because it's their performance that produces the win. But it is our role to put them in a position and give them an opportunity to win. As you all know, technology can quite literally be a game changer. When technology and human experience come together, it can elevate performance to achieve the best results possible. There's nothing like 7 Olympic gold medals to validate your data strategy. I want to share with you today how at Swimming Australia, we're connecting the value that's in our data to our high-performance coaches and athletes to achieve performance results in the pool. We're innovating with creativity to harness the power of ML, predictive analytics, and AI to create augmented decision-making opportunities for our coaches and performance teams. This enables us to get performance insights when and where we need them most, so we can win when it matters to inspire a nation through swimming. We've been developing insight applications for coaches and sports scientists to allow them to collaborate to design bespoke training programs for individual athletes, providing them with the access to the data when and where they need it most. I don't need to tell you all in the room how critical it is to have good quality data to understand performance, whether that's athletic or otherwise. There are a number of different elements that make up a swimmer's performance. So data is needed to fully understand the performance, and we need to look deeper than just the end time result. We've developed a race analysis software system called Sparta2, which we use to analyze the races in competition. This system uses machine learning to track the swimmers in a race and measures data outputs such as stroke rate, distance per stroke, and velocity, just to name a few. Using this system, we've been able to analyze not just the Australian swimmers, but all the international swimmers as well. This gives us a real understanding of events, benchmarks, trends in world swimming, but most importantly, what our competitors are doing and how they're executing their races. All of the data that we have now sits in our data lake, and this has become the simulation for continuous innovation and our foundation for our current applications and our vision at Swimming Australia. Sparta2, though, does have its limitations, and it only works in the structure of a racing environment. It isn't able to be used in the training environment. That's less structured and a much more chaotic picture for computer vision. At swimming, I always say to everyone, we want to be the Formula One of Olympic sport. And what I mean by this is the F1 teams have their car garages where the drivers bring their cars to refine them for performance. Our swimmers come to the training pool every day, sometimes twice a day, to work with the coaches and sports scientists to do exactly that. work on their skills and refine their performances and practice so that when they get that opportunity on the Olympic stage, they're able to execute their race to the best of their ability. The biggest gains for us are going to come from the training pool, and the race results are the ultimate performance test that shows us where progress has been made. So the preparation for those races is everything to us. An essential part of success for an athlete's development in training is the athlete feedback they receive. Elite athletes want to be the very best they can, so they're very responsive. The timing and delivery of feedback can be critical to the effectiveness of the data that's being provided to them. And obviously in swimming, there are constraints because a swimmer's going to have their head underwater for large parts of the training session. So there's an advantage to having the data available when the athletes reach the end of the lap. Immediate feedback will help the athlete to reinforce learning. They can relate the feedback to specific actions they've just performed and connecting it to their feel in the water. Providing data-driven feedback means it's objective for the athletes and can sometimes remove the emotion of receiving a lot of critical feedback. I'll tell you a little quick anecdote. When I was starting out as a sports scientist and a biomechanist and just learning the craft, I once had a coach say to me, "You're giving the athletes too much negative feedback. All you're doing is telling them negative things." And to which I replied, "That's my job, to find out what is wrong, how to fix it, and make them go faster." But I quickly learned it's just as important to give them the positive data feedback as well as the data on areas that they need to improve. There's an art and science to coaching, and we believe that combining the coaching experience and intuition with meaningful data is the impactful combination for driving human performance. Coaches need tools which capture and analyze athlete performance during training so that they can make data-driven coaching decisions and be able to track and monitor performance and progress. But not all metrics are useful and actually can drown out information that's really valuable to the athlete, valuable insights. An athlete's performance metrics should be developed with the coach's input so that they are meaningful and that they're going to support the coaching process. So the picture that we're trying to paint here today is that a new performance analysis system will further enhance getting the best out of our athletes in the training pool. If we can democratize it and put the meaningful athlete data into the hands of the coaches would then be able to leverage the data to make better augmented coaching decisions. Ultimately, the goal is to have real-time data insights streaming to the athletes during training. Easy, right? Well, it turns out it's not so easy. As I mentioned before, the training pool is a much more challenging environment to collect data. Unlike in competitions, where there is a defined race structure and only one athlete in each lane, in training, we could have anywhere between 2 to 8 athletes in a lane. They're swimming different strokes, different drills, stopping at different points in a lane. Anything can go on at any time. So it's a much harder place to accurately measure what is happening and to compute insights in real time. So this kind of real-time analysis system hasn't been built before. So we're really innovating and pushing the boundaries of technology in the training environment. Races can be won and lost by a fraction of a second. It is so tight that if you don't have the strategy right, there is very little time difference between winning a medal or not medaling. Just imagine if you've trained for 14 or 12 years of your life to win or lose an Olympic medal by 0.01 of a second. Pretty heartbreaking. Historically, technology in Olympic sport comes through university-style programs, which has been extensive. But this process, though, can be slow sometimes to deliver outcomes. We can't always move at the cadence that our high-performance sport moves at. AWS has had the ability to move at the cadence that high-performance sport does, which is really exciting to us. High-performance swimming is a global race, and the cadence that we're working at with AWS provides us at Swimming Australia with a competitive advantage. Together with AWS, through experimentation and innovation, we're able to build the foundation for a new training insights analysis system in only 14 weeks. The system, which we've named Training Insights, analyses video footage of the swimmers during training in real time, calculates metrics that matter, and makes them available to the coach when they need them most to enable those coach decisions to be data-driven. It's the first of its kind and a huge advantage in the race for gold. I'm now going to hand back to Annie, who's going to unpack some of the details and the architecture of this solution that we've designed together.
Thank you, Jess. It's so inspiring to hear how Swimming Australia is fully embracing technology as a competitive edge. And how cool for your business KPIs to be Olympic gold medals. It's so awesome. For the rest of this session now, we'll go deeper into the specifics of training insights, including the system architecture and the machine learning pipeline. But before we get into that, let's just work backwards and consider training insights from the point of view of the end customer, which in this case is the coach or performance support personnel. A swimming training session is broken down into multiple drills, and our solution is centered around one of those. A swimming drill is a specific exercise or technique-focused activity which is specially designed to improve a swimmer's skills. So drills work to isolate a particular component of swimming, such as stroke technique or breathing pattern or body position, and they allow the swimmer to practice and refine these specific elements without the full complexity of a regular free swim. So as an example, in a training session, there might be a drill to practice the technique of turning on the wall. And this might look like a repetitive set of 10 or 15 turns in a row. Before the drill starts, the coach or performance support personnel should manually enter some metadata into our Training Insights end user application. This metadata includes specifics on the athlete's training, like who is in which lane and if they're wearing a performance swimsuit. It also includes specifics on the training session, like if the session is in the lead up to a big race or if it's focusing on a particular technique. And this metadata all provides important context to accompany the athlete training data, which we will calculate in the drill, so that the data can be better understood in context. So for example, imagine a coach looking at some training data from a training session that happened a few weeks ago. The coach looking at this data might notice that everyone was swimming really fast in this session. But looking at the accompanying metadata, they can understand it's because everyone was wearing performance swimsuits. So that can be taken into account as part of the data analysis. Secondly, before the training drill starts, the camera calibration should be checked. Training Insights works by plugging into a camera, which is set up over the pool and streams the camera frames. This camera only needs to be set up once, and because it's out of the way, it can be left in place between training sessions. But just to make sure it hasn't accidentally been moved or repositioned, the camera calibration is rechecked at the start of each new session. This is done in the app, and we'll see what it looks like a little bit later on. And then finally, as the training drill is starting, the coach or performance support staff presses a start button in the end user application. And pressing this start button is what initiates the processing of the camera frames through the Training Insights system, and specifically through a machine learning pipeline. This multi-step pipeline detects and tracks swimmers throughout the training drill to calculate athlete training metrics. And what I mean by athlete training metrics are data metrics on performance, like how long it just took them to complete a turn or how fast they're swimming at any given moment. And these data metrics automatically stream to the application UI. So the idea here is that coaches and performance support staff can see and use this data as it's happening in the training pool to make better data-driven coaching decisions and give athlete feedback. For example, imagine a coach seeing in the app that a swimmer has just lost a fraction of a second in their turn compared to the other athletes. Seeing this data, the coach can then have a conversation with the athlete straight away to start working on ways to improve the turn. Now, considering what Jess told us earlier, that races are often won or lost by fractions of a second, this kind of tiny time precision. This kind of honing of skills in the training pool is exactly how we get the best out of our athletes and enable them to win more gold medals. After a training drill has completed, a stop button is pressed, which stops sending the camera frames for analysis. The metadata, along with the athlete training data, which we've calculated, can then be reviewed against the original video footage and manually changed if needed. And having a manual review step here is important to ensure that all the data that we've automatically captured is 100% accurate and trustworthy. And this is because we upload the data for long-term storage. So we want to make sure we're only storing the highest quality data. The athlete support team can then get the Training Insights application ready for the next drill in the session to calculate another set of athlete training metrics, and we repeat this flow. Okay, so that just gave you a view to understand the coach's feel of using Training Insights. What I want to do now is take you under the hood to understand the system architecture and how it's powered by AWS services. So what we'll do is build up the architecture piece by piece. Firstly, to track the swimmers in the pool, we set up a camera in the back stands so it has a bird's eye coverage over the pool. Swimming Australia's athletes train in multiple pool locations across the country, and all of these are open to the public. So these cameras that we install have to be strategically positioned at elevated angles to ensure that we comply with Australian PII video protection laws, while still giving us this bird's eye view that we need for the analysis. We only use this camera footage to track and analyze the swimmers, so no other wearables or sensors are needed, right? And this next bit is important. All of the data insights needed to help increase athlete performance are hidden in this video footage, and our job is to extract it. We call this an optical analysis solution, and it has quite a few advantages. One is so that it can be more easily compared with Sparta 2, which is Swimming Australia's existing optical analysis solution used in competition races, which Jess mentioned earlier. The reason that Sparta 2 only uses optical analysis on video footage is actually because wearables are prohibited in races. So we rely on analyzing video and not wearables. But as we will discuss more throughout this presentation, having a system which can generate all of the data that coaches need from only video alone is extremely powerful, and it unlocks a lot of opportunities in scaling out the solution. But we do hit a challenge here, because streaming high-resolution video frames over the internet in real time requires a large internet bandwidth. And this is a challenge because Swimming Australia's training pool facilities often suffer from unreliable and limited bandwidth connection. To overcome this challenge, we process the video on an edge device. You can think of an edge device as a sort of computer that brings data processing closer to the source, or in this case, the pool edge. By processing the data at the pool, it means we don't have to stream these high-resolution camera frames in real time over the internet, and we can calculate our athlete training metrics much quicker. So what this gives us is a hybrid solution, which combines the flexibility and scalability of the cloud with the bandwidth efficiency and low latency of the edge. For our edge device, we use AWS Panorama, which is a fully managed device and software development kit. During a training session, we turn the system on, and this is what initiates the processing of the camera frames by the Training Insights system on Panorama. We deploy the computer vision and machine learning models used to calculate the athlete training metrics onto this device as a machine learning pipeline. And this machine learning pipeline is what transforms the raw image frames to valuable performance insights. And this machine learning pipeline has been custom built with coaches' input to make sure that we're extracting the right performance metrics that are going to be the most useful for coaches. As soon as we have generated these metrics, we automatically send the results to an application which is hosted in the cloud on AWS App Runner. We use Amazon SQS to manage the communications between the machine learning pipeline on Panorama and the end user application in the cloud. So for example, the athlete training metrics that we calculate from the pipeline are sent via SQS to the cloud via a lightweight text file. So we don't have to send the high resolution image frame. And we'll see what this text file looks like a bit later on in this presentation. The coaches and performance support staff interact with Training Insights via this end user application. And this includes viewing the training metrics as they're automatically streaming in during a training session. After a training drill is complete, the calculated training metrics, along with the metadata, can be reviewed and then uploaded to Amazon S3 for long-term storage. Storing this training data like this is really useful because it means Swimming Australia can track the development of athletes' trainings over months or even years to see what were they training like this time last year. Okay, so let's pause for a second and take in what we are seeing up on the screen, which is now the end-to-end architecture backbone for Swimming Australia. What is really cool about this work is that the key principles and challenges driving this architecture unlock opportunities not only for swimming, but for a range of different sport organizations. At the heart of the system is the idea that we can increase athlete performance by providing them with real-time data metrics during training. And this idea isn't unique to swimming. And actually, all athletes would benefit from real-time data in training. We've designed here a hybrid edge and cloud architecture so that we can process high-resolution image frames in limited bandwidth environments. And this is because Swimming Australia's training pool facilities have constrained bandwidth. But again, this challenge of limited internet, it's not unique to swimming. And a lot of sport training facilities also would have unreliable internet connection. And so they could also benefit from this hybrid edge and cloud architecture. And then finally, our approach to generating the athlete training metrics using only optical analysis on video footage is also extremely accessible and useful for other sports. And actually, for swimming, we have a unique challenge that the swimmers are partially underwater. So it's harder to capture everything with the camera view. So considering all of this, what is it that makes training insights valuable for Swimming Australia specifically? It's the way we process the video footage to extract the data insights. That is the custom machine learning and computer vision models in the machine learning pipeline. Like I said earlier, all of the data insights needed to help boost athlete performance are hidden in this camera footage. And the power of our solution is how well we can extract these data insights. So for training insights to be valuable, this machine learning pipeline needs to be extremely accurate and fit for purpose. So given that these machine learning models are so crucial, let me now walk you through the machine learning pipeline, which is deployed on Panorama. And I'm definitely biased here because I'm a data scientist, so this is my job. But these machine learning models and how they interact together, for me, is the most interesting part about training insights. So I hope you all find this next bit interesting as well. The first process of the multi-step pipeline is to listen for a start signal, which is sent from the end user application via Amazon SQS. When this start signal is received, the streaming camera frames are stored over a very small batch, about a second. The batch of frames are passed to a custom deep learning computer vision model, which detects all of the swimmers in the frame. And this model has been custom trained to detect the heads of the swimmers. The pixel coordinates of these head detections are passed on to a tracking algorithm. And this tracking algorithm is able to connect the same detected swimmer across multiple image frames. So it's able to track them throughout the training drill. And the tracking algorithm specifically looks for swimmers that are moving through the water at a sensible swimming speed. And this is an important step because it acts as a really good filter. So if we've accidentally detected some pool glare as a swimmer, or if we've correctly detected a swimmer, but they're treading water and bobbing on the spot, this will get filtered out in the tracking algorithm stage because it doesn't resemble someone moving through the water at a sensible swimming speed. The swimmer's tracks are stored as a lightweight text file. For each image frame, the position of the swimmer is stored as an XY coordinate, like you can see up on the screen. And so looking at how these XY coordinates change for consecutive image frames, that will tell us how far the swimmer has just moved between these two images. But the coordinates of the swimmer, as we've given them here, are given relative to the pixels in the image. And we don't want to know how far the swimmer has moved across the image in pixels. We want to know how far they've moved in the pool, in the real world. So what we want to do is create a mapping which can convert the pixel tracks to the real world pool space. This is done with a pool calibration file and some physics calculations. This calibration is a manual exercise, but it only needs to be done once when the camera is first set up. It's done in the app by drawing a box around the pool and adding some pool dimensions. And so this is what creates for us this image to pool mapping. So with the distance that the swimmer has moved now in the real world pool space, we can then use the frames per second of the camera, meaning how many fractions of a second between images, to convert this distance into a velocity. So we can see how fast the swimmer is moving. So what we've just seen is how a head detection model, a tracking algorithm, a pool calibration file, and then the frames per second of the camera are all the different machine learning pipeline ingredients that we need to calculate some athlete training insights. And these athlete training insights are the distances swimmers have moved, the time it's taken them to, say, complete a turn, or even their velocity. And these metrics are all extremely useful for coaches. So as an example of how a coach might use these data metrics as input, imagine a coach seeing that a swimmer tends to lose a lot of time at the end of their lap. A coach, using their coach's experience, might interpret that this is because the swimmer is starting the lap too fast. And actually, a more effective pacing strategy would be to start the lap a little bit slower so that they can finish strong and can conserve energy. So an example of how a coach takes in data inputs as well as their coaching experience to make informed, data-driven coaching decisions on things such as pacing strategy. Now, by adding additional machine learning functionality to the pipeline, we can add more training insights to the list. So in particular, we run the original batch of image frames through a different computer vision model, which detects whether the swimmer is taking a stroke. Now, having this stroke detection capability, we unlock more training insights, such as the number of strokes, the stroke rate, or the distance per stroke. The machine learning pipeline outputs these final data insights as a text file, like you can see up on the screen. As you can see, the file is broken down by pool lane, contains the swimmer's tracks, and the moments they took a stroke. And the files are sent in this format to the application in the cloud via Amazon SQS. And then within the app in the cloud, they're processed a little bit further to get them in the best format for coaches to see. So Jess, how does having these training insights help you and other coaches at Swimming Australia?
Good question. Sorry. Good question, Annie. Well, this is critically important for us in training. This kind of poolside, real-time training analysis system is a world first and a true competitive advantage for our Aussie swim team. Detailed analysis of how a lap is swum gives significantly valuable information around training and racing performance, stroke efficiency, and how a swimmer is developing in all components. Being able to accurately measure specific elements with precision enables the coaches and athletes to focus on areas of strengths and weaknesses and find opportunities for improvement. There are many components that contribute to a swimmer's performance and can ultimately decide whether they win or lose a race. To really understand how an athlete is performing, we need to dive deeper into than just the overall time. When we start to break down the components, we start by breaking down a swim into free swimming time and skill time. The skill time is the aggregation of the start, turn, and finish time, which gives us our total skill time. The start is the first 15 metres, the turn is the 15 metres around the wall, and the finish is the last 5 metres of the race. So in a 100-metre race, 35 metres are made up of skill time and 65 metres are made up of free swimming. So that skill time is a significant component of a race. By breaking down the different components, we can recognise the swimmer's strengths and areas for improvement, which the coach will use to design their training plans and where to put focus in specific training sessions for each individual athlete. So the turn, if we take a little bit of a closer look at this, The turn can make up a large component, and if you think about it, in races of 200 and up, there are multiple turns that are accumulated for a total turn time. The turn you can see up on the screen is made as the head passes through the 5 meters into the wall, the time taken on the wall touch, and then they have to transition by underwater kicking and transitioning into swimming and the head passing through 10 meters off the wall. To build this capability into training insights, we need to detect when the turn is starting, when the swimmers touch the wall, and when they've completed the turn at the 10-meter mark. From these measurements, we can calculate the total turn time and further break it down into time in and out of the wall and understand what specific elements need to be improved. We can use the tracking algorithm to automatically detect when a swimmer is at the start of the turn and at the end of the turn, but capturing that exact moment a swimmer touches the wall is not easy to do. In competitions, we use a touchpad, which is a sensor-driven solution, but we don't often use these in training because they're quite fragile and they can't be left in the pool. This is where the benefits of an optic-driven solution versus a sensor-driven solution really shine for us. By building a new machine learning model that detects the moment of wall touch, from the video frames, we can calculate accurately without specialized equipment. Without having to rely on this sensor equipment, our solution's a lot more flexible and scalable. And computer vision models built for optical analysis can be extremely accurate. Okay, so up on the screen, what you can see now is the frames. Up on the first frame, you can see the swimmer starting a tumble turn and their feet flipping over. On the last frame, you can see the swimmer pushing off from the wall. But can you see the moment of wall touch? Have a look, and I'm going to show you in the next slide. It's not a trick either. What usually happens in the training environment is you'll have a coach standing on the side of the pool with stopwatches, and they're trying to eyeball that moment of wall touch. So as you can imagine, it's not very accurate. And as you can see from the images on the screen, it's very hard to eyeball that exact moment. Did anyone get it? Oh, one. Very good. By leveraging machine learning models, we're able to detect this moment to 0.08 of a second, or what we call two-frame accuracy. This accuracy is greater than the precision of a stopwatch without even taking into account the reaction time of the coach standing there with the stopwatch, which provides us then with comparable data to our race analysis data generated using Sparta. Elite athletes are extremely self-critical of themselves, and so I often have to remind them just how small the time increments are that they're chasing. So sometimes I'll get the stopwatch off the coach and actually give it to the athlete, and I'll get them to just stand there and start and stop it as quick as they can. Often just their reaction time is slower than that 0.2 of a time that we can get to using the computer vision. So it's a really powerful exercise and to give the athletes a bit of a reality check on just how small those time increments are that we're chasing. Accurate machine learning models allow us to operate at a level of precision that far exceeds what the humans are able to do. Amazing, right, Annie?
Yeah. It's really cool to see the power that machine learning can bring at such an elite level, at an Olympic level. We've given you a lot of insights into the world of high-performance swimming. So let's just take a moment now to digest the key points. Training Insights is a new performance analysis system which uses optical analysis in the training pool. It has a hybrid edge and cloud architecture, so we can process high-resolution video frames in bandwidth-constrained environments. The architecture is applicable to many different use cases, where there is a need to run computer vision models in near real time in bandwidth constrained environments. And this includes other training in sports organizations, for other sports organizations. The real differentiating value for Swimming Australia is the machine learning pipeline and how it extracts the data insights. This pipeline is made up of many different models or functionality. Combining these models together in different ways, we can calculate athlete training metrics. For example, with the head detection model, feeding into the tracking algorithm and converting from the camera image space to the real-world pool space, we can calculate distances, times, and velocities. Including a computer vision model which can detect the moment that an athlete has taken a stroke, we can add more training insights to the list, like stroke mechanics. And all of these data metrics are extremely valuable data insights, which help coaches make better data-driven coaching decisions and give athlete feedback. And now Jess just talked us through how adding a wall touch machine learning model to the mix gives us all the capability we need to capture the elements of a swimming turn. And this is just the beginning. Hopefully, we have given you the sense that this optically driven system can unlock a lot of opportunities. Now, by using the architecture backbone and the machine learning pipeline as the foundation, we can build all sorts of computer vision models to calculate many more training insights without the need for adding additional hardware or sensors, which doesn't scale easily between pool locations or between athletes. So for example, we could create custom machine learning models to detect the moment the swimmer is taking a breath, when they first break out from the water, to detect their kicks, or even to detect the fraction of a second reaction to the start gun at the start of a race. To incorporate all these new capabilities, all we do is deploy them as separate models into our already existing architecture backbone and machine learning pipeline. So Jess, why is it important for you and coaches to have access to lots of different data metrics?
Well, Annie, we rarely look at performance in isolation. So having multiple data inputs allows us to build a more powerful and complete swimming strategy. For example, the breakout's another really important performance element. The breakout's the technical term in swimming for when the athlete's head surfaces transitioning from their underwater kicking up into free swimming. And it's a time and distance that is the data metric that's given to the athletes. This is an example of data that we would layer on information to the turn example that we've just provided. Layering on extra information, we get a more complete picture of different elements, making up a turn so it can be more precisely optimized for each individual. The more data points we collect, whether it's breakout, breaths, or kicks, the more precisely we can fine-tune an athlete's technique and performance. This allows us to not only address immediate improvements, but also predict how one change might affect a different area of a race. The integration of these diverse data points enables us to refine every element of a swimmer's preparation. The more comprehensive our data, the more accurate and effective our coaching, leading to smarter, more personalised training and better race outcomes. In the end, the combination of data and training insights that empowers our athletes to perform at their best, turning every fraction of a second into an opportunity for success. This new systems unlocks so many exciting opportunities for us in performance support teams, coaches, and for athletes. And we're now just at the beginning. At the Paris Olympics, we closed the gap to only one gold medal to the US. But with that metal gap closing and powered by cutting-edge AWS technology, we're already setting our sights on big things for here at the LA Olympics in 2028, and then when we're going to have the home ground advantage in Brisbane in 2032. High-performance swimming is a global race. You know the goal is to win gold medals, as many as we can possibly win. But in order to do that, you must continue to innovate and improve, and that will never stop for us. So thanks for listening to us today, and we're going to open up the floor for any questions that you might have. So I'm going to ask Annie to come back onto the stage, and Annie's happy to answer any questions around machine learning and the architecture. And I'm also going to invite to the stage Paul Devlin, who's the Global Business Development Officer for Sport at AWS and works across many sporting organisations and related businesses for AWS. And of course, I'm happy to answer any.
I thought we had a.
Keep